Dear students, welcome to today's class. In this class, I am going to explain some very important problems which were given in the previous JEE mains examinations from the chapter complex numbers. So yesterday I have explained a few very important basic concepts of complex numbers. Using those complex numbers concepts, now we are going to solve some problems. Okay na? So see the problems, how to solve, what are the problem solving techniques, in a short time how to solve these problems. So let us see the problem. Okay, right. So the first problem is, if alpha and beta belongs to R, that means both alpha beta are real numbers, are such that 1 minus 2i, where I square is equal to minus 1, as it is a known fact, is a root of z square plus alpha z plus beta is equal to 0, then the value of alpha minus beta is equal to. So this is a question asked in 2021 mains examination. So options are also readily available. So very easy problem. So this is given a quadratic equation in the z square plus alpha z plus beta is equal to 0, and he is given that one of the root is 1 minus 2i. Generally what we will do, so we will substitute. So we will substitute wherever z is there, we will substitute 1 minus 2i. Just substitute here. So that means 1 minus 2i whole square plus alpha into z means 1 minus 2i plus beta is equal to 0. Right. So this is a minus b whole square, a square minus 2ab, that means 4i plus b square, that means 2i square. I square means minus 1, that is minus 4, plus this is alpha minus 2 alpha I plus beta is equal to 0. 0 means 0 plus I into 0. Clear? What are the real parts? So tell me what are the real parts. Here 1 is there, minus 4 is there. 1 minus 4 plus alpha plus beta is equal to 0. There, that side also real part is 0. So this is equal to alpha plus beta is equal to 3, is called as equation number 1. What are imaginary parts? Imaginary part. So here what is imaginary part? This is a minus 4. So here minus 2 alpha is equal to 0. So from this alpha is equal to minus 2 we got. Okay, very nice. So substitute alpha value minus 2 here. So this is equal to minus 2 plus beta is equal to 0. Beta is equal to 3. Therefore beta is equal to 5. Understand? Now he is asked to find out alpha minus beta. That means alpha minus beta. What is the value of alpha? Minus 2 minus 5. Minus 7 is the correct answer. So option D is the right answer. Okay. So very easy problem this is. Generally students will get, they will start doing that. Let us take z is equal to x plus iy, and they start doing that. So no need to do. So it is, he is given that it is a quadratic equation in the complex numbers z. Already z is a complex number, 1 minus 2i is given. Just you substitute here real parts and imaginary parts, we equated and we get the answer. Very easy problem. So this was asked in 2021. Okay na? I hope that you understand this solution. So let us go for next problem. Dear students, welcome to second problem. The second problem is, if x plus iota y is equal to 2 to the power of 1008 upon 1 plus I power 2016 plus 1 plus I power 2016 by 2 to the power of 1008, then the value of x and y. Okay, it's a one of the easiest problem. So if you know the properties of iota, yesterday class I explained about the properties of iota. The problem is very easy. So once again I will revise those properties of iota. So here I to the power of 4n, that means 4n, it is a, if it is a multiple of 4, that means where n is an integer, its value is 1. I to the power of 4n plus 1, its value is I, multiply with I, 1 into I. If it is iota power 4n plus 2, that is into I into I square minus 1. Iota power 4n plus 3 is equal to minus I. That means if you know the first one, remaining 3 are very easy. Iota power 4n is equal to 1, that everybody knows. Multiply with 1, multiply with I, 1 into I. Multiply with again I into I square minus 1. Minus 1 into I minus I. Understand? So this is iota power 4n plus 1, 4n plus 2, 4n plus 3. Consecutive integers. Okay now, right. So whatever may be the number, iota power 4n, 4 times n, multiple of 4. If you write down, that value is 1. Right. Now coming to here, first I will try to find out the value of 2 power 1008. It is a very clear. Now see here, 1 plus I power 2060. This I will write it as 1 plus I whole square whole power 1008. Can I write it? A power m whole power n. A power mn. Right. A plus b whole square. A plus b whole square is how much? 1 plus I whole square. A square plus b square. I square value minus 1 plus 2i. Plus 1 minus 1 cancel, 2i. Understand? So this is equal to 2i power 1008. So this is equal to 2 to the power of 1008 into I power 1008. So it is a very clear. What about this value? That now you have to use the make use of the properties of iota. So this is equal to, can I write down I to the power of, first try to find out writing it's a multiples of 4, that is equal to 4 times, can I write it? It is a multiple of 1008 is a multiple of 4. So see here, how can you write down 4 2s are 8 and 4 5s are 4 2s are 252. So this is equal to I power 4n and its value is complete. This value is 1. This is equal to 2 to the power of 2008. 2 to the power of 1008. So its value is 2 to the power of 1008. So its value is 2 to the power of 1008. So this will get cancelled and it will get cancelled. So x plus iy is equal to, you will get 2. 1 plus 1, you will get 2. 2 means what? 2 plus 0 I or I0. Therefore x value is 2, y value is 0. X value is 2, y value is 0. So clearly the option C is the right answer. Okay, now the only thing what you have to remember to solve this problem is 1 plus I whole power 2016, that is 2 into 1018. 1008 is a multiple of 4. Clearly a plus b whole square, it will become 2i. Afterward the problem is a very easy. Okay, now so I hope that you understand this solution. Let us go for next problem. Dear students, let us see the third problem. If the real part of the complex number z is equal to 3 plus 2i cos theta upon 1 minus 3 iota cos theta, where theta belongs to 0 to pi by 2 open bracket is 0, then the value of sin square 3 theta plus cos square theta is equal to, right. So a very easy problem it is. It was asked in 2021. So what is the problem? So here one complex number is given, that is 3 plus 2i cos theta by upon 1 minus 3 iota cos theta. Okay, now its real part is 0. The real part of the complex number is 0. Generally it is not in general form. What is the general form of a complex number? A plus bi. That is, it is a real part is equal to 0. Generally students, what they will do? They will multiply the numerator and denominator with the conjugate of the denominator. Just you do also like that. So this is equal to 1. What is the conjugate of 1 minus 3i cos theta? This is 1 plus 3i cos theta by 1 plus 3 iota cos theta. Okay. The thing what I am going to do is, don't do the complete calculation. Don't do the complete calculation. Why? Because anyhow the real part of this is equal to 0. A will become 0. Understand? Don't multiply the denominator also, don't multiply. So what is the real part? So this is a 3 and you multiply these two. That's all. If you multiply 3 into 3i, you will get an imaginary part. If you multiply 2i cos theta with 1, you will get an imaginary part. Don't do that. So just 3 into 1, 3. So 2i cos theta into 3i cos theta, that is equal to 6i square cos square theta. That means minus 6 cos square theta. This is equal to 0. This is real part of Z. That's all. Very simple, very simple. Don't do complete calculation. Even though if you do the complete calculation, this is the real part. And what is the imaginary part? Even though it is not necessary, I am doing. What is the imaginary part? 3 into you multiply 9 cos theta, 2 into 2 cos theta into I plus 2 cos theta, that is equal to 7 cos theta. So this is a real part and that is the imaginary part. Understand? So why I am explaining this problem is don't do the complete problem. Now from this, therefore, so cos square theta is equal to, so this is equal to 3 upon 6, this is equal to 1 by 2. So cos square theta is equal to 1 by root 2 whole square. So this is equal to, so therefore cos square theta, therefore theta is equal to, cos theta is equal to 1 by root 2 you can take. Therefore theta is equal to pi by 4. Actually you will get infinite number of solution, but here observe here, theta lies between in the first quadrant. Enough. Cos theta is equal to 1 by root 2, right? So now substitute in this here. So this is equal to sin square 3 into pi by 4 plus cos square pi by 4. So this is equal to 3 pi by 4, 3 into 45. So this can be written as sin square pi minus pi by 4 plus cos square pi by 4. So this is equal to sin square pi by 4 plus cos square pi by 4, which is nothing but 1. 1 is your right answer. So from this problem, what you have to learn? What you have to learn is, the problem is the only thing is, don't try to convert this in the form of a plus bi, just like how you will do in the board examinations. In the board examination, it is a compulsory that you have to convert it into a plus bi form. You have to show that it is a real part and it is imaginary part separately. But here no need to do that. So the real part is just to multiply the real part of Z, means real parts, imaginary parts multiply, you will get the real part of Z. Understand? So after getting the real part, just to substitute the values, you will get that. So within a minutes you can solve this problem. Okay, I hope that you understand this problem. Let us go for next problem. Dear students, welcome to fourth problem. All the points in the set S is equal to alpha plus iota upon alpha minus iota, where alpha is a real number, and also where I is equal to root of minus 1 lie on A. So options are available. Straight line whose slope is 1 na, let us say circle whose radius is root 2 na, circle whose radius is 1, or straight line whose slope is minus 1. Let us see that. First of all, here one set is given. Z S is equal to, the set contains the complex numbers. That means alpha plus I by alpha minus I. What is this? Is a complex number. Alpha plus I by alpha minus I is a complex number. Of course, it is not in our general form, A plus bi form, it is not there. Just on the whole, the set S contains the complex numbers. Let Z is equal to alpha plus I by alpha minus I. Let ZB be the complex number X plus I, alpha plus I by alpha minus I. Now you have to find out the locus of X and Y. For that, a very general students, what they will do, no, they will start trying to convert this complex number alpha plus I by alpha minus Y into general form, X and Y form, X plus I by form, and they will equate X values and Y values, and again eliminating alpha takes a headache. The only thing is very easy, apply the modulus on both sides. Apply the modulus on both sides. So what is the modulus of X plus I by? Yesterday I explained. What is the modulus? root of x square plus y square. So we have the property of modulus, that is a modulus of z1 by z2 is equal to modulus of z1 by modulus of z2. Of course, here z2 is not equal to 0. So there also surely alpha minus I is not equal to 0. Sure. Why? Alpha is a real number. For any value of alpha, alpha minus I cannot be equal to 0. Alpha minus I cannot be equal to 0. That's why we can apply. So modulus of alpha plus I is equal to root of alpha square plus 1 square. This also root of alpha square plus 1 square. These both will get cancelled. You will get 1. So root of x square plus y square is equal to 1. So this is a x square plus y square is equal to 1. So anybody can say this is a circle with the center 0, 0 and radius 1. So option C is the right answer. So from this problem, from this solution, what you have to learn? What you have to learn is you have to apply the learn this problem solving techniques. Okay, generally students what they will do now, so immediately they will try to convert. So this is equal to alpha minus I, no, they will start alpha plus I by alpha plus I. This is a plus b whole square, here alpha square minus I square, and they will take real part separate, imaginary part separate. So don't do all those things, just apply modulus on both sides, you will get the answer. Okay na? I hope that you understand the solution very nicely. So let us go for next problem. Dear students, welcome to fifth problem. The very easy problem this is, which was asked in 2019 mains. If A is equal to the set containing the complex numbers 3 plus 2i sin theta upon 1 minus 2i sin theta, where theta belongs to the open bracket minus pi by 2 to pi, is a purely imaginary number. That means what are the complex number that belongs to the set A, all are purely imaginary. That means all their real parts are equal to 0. Then the sum of the elements in A is, that means what are the complex numbers which belongs to A, their sum is how much. Okay, first we will find out what are the complex numbers which belongs to the set A. So here, so the set consisting of the complex numbers z is equal to 3 plus 2i sin theta upon 1 minus 2i sin theta. Okay, now it is a purely imaginary number. That means purely imaginary means what? The real part of z is equal to 0. To find the real part of z, we have to convert it into general form. To convert into general form, we will multiply the numerator and denominator with the conjugate of the denominator. That means 1 minus 2i sin theta. What is the conjugate? 1 plus 2i sin theta upon 1 plus 2i sin theta. Okay, now to find the real part of z, already in the previous problem I told, so this 3 is a real part, here also 1 is the real part, so multiply, that is a 3, 2i sin theta, multiply, so 2i into 2i minus 4 sin square theta, this is equal to 0. Enough, don't do the complete problem. Okay, now so this is equal to sin square theta is equal to 3 by 4, sin theta is equal to plus or minus root 3 by 2. Don't go for general solutions. Why? Because here the domain is restricted to minus pi by 2 to pi. So no need to write down the formula of general solution of the trigonometric equation. So here you will get that clearly theta is equal to very clear minus pi by 2. Minus root 3 by 2 means how much? Minus root 3 by 2 means minus 60. Minus 60 belongs to this, that is a minus pi by 3. Plus root 3 by 2 means plus 60, that is pi by 3. Understand, one more chance is also there. Root 3 by 2 means it is up to 8, no, 120 degrees. 120 degrees means 2 pi by 3. 120, sin 120, 180 minus 60 belongs to the second quadrant. Okay, therefore that is also sin 60 root 3 by 2. So therefore what is the sum of their angles? That means sum means minus pi by 3 plus pi by 3 plus 2 pi by 3. Sum will get 2, those 2 will get cancelled. So your answer is 2 pi by 3 is your right answer. Understand? So very easy problem this is. From this also the what you have to learn is to get the real part of the complex number, don't do complete problem. Okay, now? So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to sixth problem. Sin x plus I cos 2x and cos x minus iota sin 2x are conjugate to each other for which values of x? For which values of x? Okay, now that means these two complex numbers, that is, these two are conjugate to each other. That means the conjugate of sin x plus I cos 2x is equal to cos x minus I sin 2x, or the conjugate of cos x minus iota sin 2x is equal to cosine x plus I cos 2x. That means on the whole, sin x plus I cos 2x is equal to the conjugate of this. That means what are the conjugate of that? Cos x plus I sin 2x conjugate. Otherwise you can take another way also. Cos x minus I sin 2x is equal to sin x minus I cos 2x. So from that, for what values of x this equation is valid. Okay, now? So let us take the real part separate and imaginary part separate. So this is equal to real parts is sin x cos x here, cos 2x is equal to sin 2x. So this is equal to tan x is equal to 1. So this is also tan 2x is equal to 1. From this you can easily check whether for what values of this tan x is equal to 1 and tan 2x is equal to 1, what values both will be equal. So if you see that tan x is equal to 1 and also tan 2x is equal to 1, clearly for no value of x, but even then we will check. X is equal to 0 cannot be your answer. Why? Because put tan 0 is equal to 1, no. Tan 0 is equal to 1, no. Therefore, x is equal to 0 cannot be your answer. Next one. Pi, if you observe here, n is equal to pi by 2. For example, if you substitute n is equal to 0 here, pi by 4 you will get here, pi by 4, where n is an integer. Put 0 here, pi by 4. Tan pi by 4 is equal to how much? 1, okay. But here pi by 4, substitute pi by 4 here, pi by 2. Tan pi by 2 is not defined. That means you have to, that means x is equal to pi by 4, it's satisfying first equation, and but it is not satisfying the second equation. Therefore, this is also your not answer. Particularly here also, if you put n is equal to 0, here you will get 0, x is equal to 0. Already we see that x is equal to 0 is not your answer. So option A and option B and option C, they are not their answer. For the one and only option remains is no value of x. But generally it is a option verification we did. But sir, theoretically how can we say, sir, as we can say this x is equal to take the general form. So n pi plus pi by 4. So this is equal to 2x is equal to n pi plus pi by 4. X is equal to n pi by 2 plus pi by 2 4s are 8. So we have to take the common solution, whatever may be this common solution we will take. Okay, so let us observe this common solution. I will take like this. How we can take? So let us take a two-dimensional circle. So this is x-axis and y-axis, z-axis. So if you observe, pi by 4 will be here. So here pi by 4. N pi by 4, that means 1 pi, 2 pi, 3 pi, 4 pi, 5. That means what? It will come again, your next number will be, this is n pi plus pi by 4. That means if it is pi by 4, next number is pi plus pi by 4. Next number means 2 pi plus pi by 4 means again it will come. So your numbers will rotate like that. So next one, pi by 8 means, somewhere here it will be there, half of pi by 4, pi by 8. Pi by 2 plus pi by 8, that means the next number will be what? Perpendicular here, it will be here perpendicular. Otherwise, if it is, we can take here n means, so we can take m here, no problem, we can take m, it's different. Next pi by 2 means the perpendicular means this may be answer. Why? Because if you take m is equal to -1 minus pi by 2 plus pi by 8 like this. This is another number will be here. So this is a pi by 8. This is a some m pi by 2 plus pi by 8. This is a minus m pi by 2 plus pi by 8. From this what you can observe. So is there any intersection here? Is there any intersection? Nothing. So here pi by 4 will be there. Otherwise, next number will be here. For the second set, if the number is one of the theta value is x value is pi by 8, otherwise here. That means it will be rotated like that. Is there any intersection part you will get? Nothing you will get. Nothing you will get. So therefore, you are generally option verification also you can say. Otherwise, theoretically, if you want to say that theoretically, you can prove that. So these set of values will rotate like this. Pi by 4, 3 by 4. This number will rotate like this. Okay. Second set of values will be like this. Understand this? So this is for no value of x, the conjugate of sin x plus I cos 2x and cos x minus I sin 2x, they are equal to each other. Okay. So dear students, I hope that you enjoyed this today's class. Very nice. And yesterday's class and today's class all are about complex numbers. Okay. So in the tomorrow's class, I will come before you with calculus. Okay. So we will switch on to calculus problems. Okay. So until then, goodbye.